Hi everyone, welcome to the new episode of our Brown Black Meetup series. I'm your host Alik, and we are kind of think space of blockchain engineers, of blockchain enthusiasts, and of everyone who is interested in the early adoption of this technology. And this event is brought to you by blockchain professionals in collaboration with Zeeve.io. This is a series of webinars. There will be 4 webinars, and this is our second one dedicated to DeFi. And today we are here to discuss about the core components of DeFi together with our guest, Dr. Ravi Chamria. Hi, Ravi. How are you?
Yeah, hi, I'm doing fine.
Yeah,
How?
thank you for being with us today. I cannot see your video, but yeah, I hope it will be fine. Yeah, now it works. So without further ado, I will bring your presentation to the stage, and I hope we can see it now. Good luck to you. We will discuss all the questions at the end.
Sure. Thanks. Hi, everyone. My name is Ravi. I'm the co-founder CEO of Zeeve, and this is the second episode in our DeFi series. So, first, just recap what we covered in the last episode, the episode number one. So we talked about the core DeFi infrastructure. What are the core components of DeFi infrastructure? And what is DeFi? How decentralized finance is different from the traditional finance. So some of these areas we covered. Um, so just to recap, if we talk about centralized traditional financial systems, we see that there's a custodian. Custodian manages everything, so there is always intermediary, and intermediary charges a fee to do all kind of financial services or transactions. Vis-a-vis that, decentralized finance is based on blockchain, based on decentralized ledger, and the whole idea is to reduce the role of intermediaries or omit the intermediaries altogether in certain transactions. So, what are the core components? One is having a blockchain protocol, a decentralized ledger that provides trustless transactions without involving intermediary, and they are decentralized in nature. They are distributed, and at the same time they support smart contracts so that you can write complex business logic. So it's not just about simple send and receive transactions, but you can do more complex transactions, enabling various different financial products, whether it be investment products, whether it be insurance products, and so on and so forth. And then we have oracles, because smart contracts are designed in such a way that they cannot query an external data, off-chain data, which is outside the blockchain system. So we have oracles which allow us to take the data from outside, from external data feeds or databases or external world, into the smart contract, so that based on that data, decisions can be taken or triggers can be applied in the contract logic. And today we have decentralized Oracle players like Chainlink and so on and so forth. And we talked about decentralized applications in general, but yeah, and then there are various other components like stable coins that we know are are the heart and soul of DeFi systems, because they enable trading when we know that most of the utility tokens are highly volatile in nature. So these were a recap of what we covered in the episode one. Today we are going to jump in a bit deeper, and we are going to talk about the various DeFi primitives. What are the different areas that or features or characteristics of DeFi that we typically use? So, what are the different pieces that we are going to use? Are one, what are the transactions as we understand in the case of DeFi, and then different kind of tokens, whether it be fungible tokens, non-fungible tokens. We'll also talk about custody and escrow services, what kind of escrow contracts are there, and then a bit about collateralized and flash loans, and then what are the token supply mechanisms, like burning tokens, minting, or the bonding curve, and then token swaps, and then something about staking rewards and penalties. So first, let's take up the transactions. So transactions, and I think the content is based on Ethereum, and is largely applicable to most of the blockchains today. So there are two kind of accounts in Ethereum. One is externally owned account, which is a wallet account, and the second is a contract account. So the transaction typically when you are sending a message as an account owner to someone, and that transaction is recorded on the blockchain. Now, this transaction can only be originated by an externally owned account. So, typically, when you have your MetaMask wallet, you have a wallet address, a public address. So, you're actually sending transaction from your wallet. Let's say you want to send a certain number of tokens to another user. So you're using your externally owned account because the set of private and public pair address is actually outside the Ethereum blockchain. So you use that, and that transaction get recorded on the blockchain. But then there are smart contract transactions also. Like you can again you will use your externally owned account to start the transaction, but then you can based on a certain transaction, a smart contract can be triggered, and some actions can be taken. The classic example being, if you have bought an NFT on, let's say, OpenSea. So in OpenSea, when somebody wants to sell an asset, an NFT, they are signing a marketplace contract or selling contract, by which they are allowing the OpenSea smart contract to sell you NFT whenever somebody is willing to pay the required amount that you have set. So let's say you want to sell your NFT for 1 Ether, and you have put that, you have signed the contract, you have signed using your private key uh, on the OpenSea selling contract or the marketplace contract, that you want to sell this NFT. And I, as a user, come there, and I connect my MetaMask, and I willing to pay 1 Ether. Then as soon as I pay 1 Ether to the OpenSea contract, the NFT will be transferred to my account. So that is where an external action can and trigger an action in the smart contract. Um, and then there are various small pieces in a transaction. So one, transactions in DeFi are atomic in nature. And when we'll discuss about some other primitives, we'll see that atomicity is something which is very, very important, and a lot of use cases actually come out of atomicity. So what we understand by atomicity is that the transactions in DeFi are atomic in nature. So when you start a transaction, so take an example of an escrow. So if, or the same example I gave for OpenSea. So as soon as I transfer 1 Ether to the smart contract, then only the NFT will come to my account. If, let's say, for some reason or the other, the NFT is not available to come to my account, my Ether will be reversed back to my account. So that is what we mean by atomicity, that the transactions will be reversed as the transaction never happened. If there is some challenge, it may be a set of 4 transactions or 10 transactions. So wherever there is a failure, it will automatically reverse back. The second is use of gas, and gas is a mechanism. It's like a rent being charged on each transaction that happens. So there's a mechanism in smart contracts, and I think we all users of different blockchain platforms, we have used to paying gas fee. If you are transferring, let's say, a simple transaction from your wallet to another, you are paying a certain gas fee to execute that transaction. And that gas fee is something very important, because gas fee acts as an incentive either to the protocol in some part, or to the validators who are actually validating the transactions. So this gas fee is utilized in different ways depending on how the smart contract is using that gas fee. And there's a gas fee limit. So let's say when you're executing a smart contract, and let's say the code in the smart contract is faulty, because as the size of the transaction increases, the gas fee increases. And so if the code is faulty and the gas, it consumes a lot of gas, so there's a gas limit. Beyond that gas limit, the transaction will fail, and all the gas fee that has been spent will be a waste for the user. But yes, at the same time, the validators will be incentivized because they have done the work, or the platform has done the work. Other factors in gas fee, that gas fee is based on an auction kind of process. So just imagine that uh, a block of transactions is being written at a certain frequency, like every 3 seconds or every 5 seconds. Now During that time, all the transactions that come on the blockchain are packaged into one block of transactions, and every transaction is associated with a gas fee. So since there is only a set number of transactions that can be packaged into a block, um, so what happens is that the transactions compete with each other, and that's why the transactions which pay more gas fee is something that the validators would be more interested in including in that block, and move rest of the transactions in the subsequent blocks. So that way, the gas fee may increase unpredictably, like we have seen whenever a huge activity occurs, like cryptokitties happen. Suddenly the gas fee on Ethereum became huge, and today we see that to solve the gas fee and solve the scalability challenges, we see there was a surge of layer twos and different rollups and so on and so forth, to how to move transactions away from Ethereum main chain to the side chains or off chains. Another concept here is mempool. So the way the transactions are designed, so when you do a transaction, all the transactions are compiled and they remain in a mempool before they are a block is selected and the transactions are committed on the blockchain. And this mempool, the miners or the validators can actually see all the transactions in the mempool, and that may give rise to challenges like front running. But that's how the blockchains are structured. Now there are a few blockchains are coming in who are who have one either abstracted the whole mempool layer, or have put in some kind of privacy where even if the mempool is there, the transactions are not visible to exploit the front running piece. And then there's another concept of minor extractable value, which is basically that validators can see all the transactions and they will want to extract maximum fee out of it. So they will try to include transactions, or they will sequence the transactions so that they can maximize the profitability for each block that they write on the blockchain. So these are some of the pieces when we talk about transactions in DeFi. The second piece is tokens, like the different token standards. So there are primarily two type of tokens: fungible and non-fungible tokens, and we'll briefly talk about semi-fungible tokens also. So fungible tokens are backed by assets. So like we have a definition of fungible assets and non-fungible assets. So fungible assets are assets that are exchangeable with each other. For example, $100 bill, $100 bill, $200 bills are completely fungible with each other. So if a token represents such kind of asset, a fungible asset, it is called fungible token. And the common standard for um, creating fungible tokens is ERC20 on Ethereum and pretty much all EVM compatible chains. So you can create tokens which represent a certain value or certain asset. It may be a utility token, which it may be an enterprise value or a network value that it represents. It may be voting rights. It may be some other assets. Like in the case of stable coins, USDT, USDC, it is backed by fiat. So these are fungible tokens. And there are three types of fungible tokens based on the utility or the types. One is the equity token, second is utility token, and third governance tokens. So first, let's talk about equity tokens. So equity tokens basically where a token represent a certain pool of assets. So let's say there is taking a simple example of there's a pool, like we have seen in the case of funds. They have a pool of, let's say, 100 ether, and then you to define the ownership of that pool, you launch a token, and let's say there are 100 tokens. So one token will be equal to one ether in this case, because the fund has got 100 ether, right? So that's how basically an equity token represents a pool of assets. So it can maybe a static pool, like the example I gave, where you have a pool of 100 ethers. But then the pool of assets can be even more complex. They may have some kind of variable rate mechanics, like in the case of compound, or they may have multi-asset pools with complex fee structure, like in the case of Uniswap. So Uniswap, as you know, is a decentralized exchange where you have token pairs provided by liquidity, providers. So that is a different kind of pool. And when you provide a liquidity pair, you get LP tokens in return. And then there may be standard interface for creating equity tokens with static or dynamic holdings, which is like set protocols allows you to do that. So equity tokens are important type of tokens. They are fungible tokens because each token has to be fungible with each other when they are representing a pool. Then utility tokens, which are the most common tokens today in the blockchain world. Most of the tokens that we have seen during the ICO sale and the native tokens of each blockchain protocol, they are primarily utility tokens. So idea of utility tokens is that they represent utility, and the utility needs to be established for a token to be called a utility token. So if we talk about, let's say, Ether, in the case of Ethereum blockchain, so Ether is the a native token of Ethereum blockchain, and it is required to pay the gas fee, and the gas fee is required to execute smart contracts or fulfill the transactions. Because the whole incentive method, if there is no gas fee, the gas fee cannot be shared with the validators or the miners, and they will not have enough incentive just by the new tokens to write the new blocks. So the entire blockchain system is running on that token. That's why it's called a utility token. It may be used as collateral, like in the case of synthetics, and stable coins, as we see, are all utility tokens, where they are backed by a certain. It may be fiat collateralized, or it may be crypto collateralized, like we see in the case of DAI, or it may be algorithmic, like what we saw with the case of Terra Luna, etc. So all these are utility tokens. And the third type is governance token. So governance token is very much similar to like equity tokens, but in the case of equity tokens, we talked about a pool of assets. In the case of governance tokens, it is not the pool of assets, but it is the voting rights or the governance rights to a specific protocol or an application. And today we use decentralized autonomous organizations to define how a certain protocol or an application will be governed. So these are governance rights or governance, and token holders uh, have access to these governance or voting rights, and these kind of tokens are called governance tokens. So governance tokens, again, depending on the supply, they may be static in the sense that there is a set number of governance tokens that have been launched for a certain protocol, like in the case of MakerDAO. And token holder, each token is fungible with each other, but each token holder holds a proportionate value in this. But then there may be variations, like um, there may be rewards for not just holding, but for voting on different rights. Sometimes when a proposal is made, and the token holders, the governance token holders, are voting on it, so only the people who are participating in a certain proposal are paid the rewards, or it may be all the token holders will get the rewards. Some of the governance tokens are listed themselves, they have appreciative value, they are tradable, and so on and so forth. So there are various options there. So that was fungible tokens. Now coming to non-fungible tokens. So non-fungible tokens are tokens which represent non-fungible assets. So if you talk about, let's say, real estate or digital art collectibles, or it can be a peer-to-peer loan, or so these are different non-fungible assets, and the token which are designed to represent these kind of non-fungible assets are called non-fungible tokens. Primarily two standards, ERC 721 and ERC 1155. And then there are now some more variations of token standards specific to different asset classes, maybe, for securities, for real estate, meeting different compliances, etc. But traditionally, these are the two commonest token standards. ERC 721 basically defines the non-fungible standard, and it's the most common. Like if you go to OpenSea, Rarible, any NFT marketplace, most of the NFTs that you see have been created using an ERC 721. But yes, there are some kind of assets where you require non-fungible tokens as well as you require fungible tokens. And if you want to have a combination of two, that is where ERC 1155 comes in, which allows you to represent both fungible and non-fungible tokens together. And then there is a concept of semi-fungible tokens. So semi-fungible tokens are basically tokens which are fungible to start with, but as their face value or the face price expires, after that they become non-fungible. So some of the classic examples being like vouchers. So vouchers, they each voucher which has got the same expiry, they are fungible with each other. But once the expiration date has passed, post that, each voucher becomes a non-fungible token. Similarly, in the case of event tickets, there are a lot of event platforms today, and a lot of initiatives have happened in the case of ticketing platforms in the form of NFTs. So there, before the event has happened, these NFTs are fungible with each other. For let's say, assuming there's only one class of tickets for a specific event. So in that case, all these NFTs are fungible with each other. But as soon as the event is passed, event is finished, after that, this will turn into a non-fungible token. So this was about the fungible and non-fungible tokens. And as I mentioned, now things have moved from digital collectibles to real world assets. And when we talk about real world assets, simpler 721 and 1155 standards, they do not fulfill all the requirements of real world assets. But that's a topic for another day. But the idea is that there are quite a few new standards that have come up, which takes care of pieces like decentralized KYC or the compliance requirements, geographical restrictions, jurisdictions, etc. So next topic we are covering today is custody or the escrow. So escrow contract, as we took an example in OpenSea, there are various DeFi platforms. You'll see the flavor of escrow contract, and the whole idea is to have escrow being governed by a smart contract. So traditionally, we have seen escrow or custody being a third party, where there's a third party which holds the custody of assets, and any kind of transaction can happen through a third party. In the case of DeFi, what we are talking about here when we say custody or escrow, we mean escrow contracts or custody contracts, and they are governed by smart contract where the set of conditions are written, and as the conditions are met, the decision is taken. So that's how the escrow contract works. Taking a simple a business transaction, so let's say A is supposed to do a certain action or a certain work, and B is supposed to pay when the work is completed to A. Now, B is going to load the funds that need to be paid in future into the smart contract, and the A needs to submit the transaction in the blockchain once the work is completed. It needs to be provably submitted in the contract, and once that is done, automatically the fund which was deposited by B will be passed on to A. So this is like an escrow contract, and you can see there are innumerable use cases where we can see the usage of escrow contracts. The best part is that user retains the custody of the assets. The assets are, so let's say if the A has not completed the work, then the user B can anytime withdraw the funds. So it can revoke the contract and take out the funds, withdraw the funds. So the funds are not at risk that B has paid the funds but has still not got the work that needs to be done against the funds. Um, there may be some challenges in terms of smart contract, like if there's a challenge in the smart contract. It has happened in practice where you deposited fund in a contract, but a proper mechanism or a business logic has got some fault, due to which the funds are permanently locked into the contract. There's no way to take the funds back from the contract. The next topic we talk about is supply adjustment. So in supply adjustments, we'll primarily talk about how the token supply is managed in the market. So one, how to increase the token supply, where you mint new tokens or you reduce the token supply. So creating an inflationary and deflationary token economics. So the first process is minting of tokens. Now, minting of tokens means you are minting new tokens and put them into circulation. Now, there are various use cases where this can happen. One is traditionally we have seen in proof of work as well as proof of stake blockchains that the validators or the miners are there rewarded by minting new tokens. So that is one, where you're minting new tokens, and in fact, sometimes we have seen some protocols they pre-mine certain tokens when they launch, so that again you are minting tokens. Um, so whether it be pre-mined or it is based on certain activity, the new tokens are minted. The tokens are sometimes used as a not just for the miners but other reward mechanisms or to align certain user behavior. For example, there may be a certain tokens based on somebody who is staking or doing some activities on the platform. So let's say there's an NFT marketplace and they want to reward all the users who are doing buy and sell transactions or minting NFTs on the platform. So to do this, new freshly minted tokens can be minted and given to the users. So there may be different methods. It may be that some of the tokens are pre-mined and allocated to be distributed to the early users or rewarding the early users of the platform. Or it may be that these tokens are logged in the contract and they are minted as the time comes, on a weekly basis, whenever the rewards need to be given to the users. The opposite process is burning the tokens. Now, the mechanism of burning the token is bit different as compared to minting. Minting, I think, is very straightforward. You define the logic in the smart contract. Based on certain triggers, you can mint the new tokens. In the case of burning, you send the tokens to either an unknown address, a burn address, which cannot be used to take the tokens out of it, or you can write a burn function in a smart contract and you can use that function to burn the tokens. So basically, in both the processes, the end result is that the tokens become unusable and nobody would be able to use the tokens. So that is what burning the tokens is. The downside is that, in the case of burning the tokens, it does not impact, there's no way you can know that some of the tokens have been burned. Like, for example, today we say that, okay, the total supply for Bitcoin is so and so, or Ether is so and so, but there are quite a few wallets who have lost their private keys. So those tokens are permanently locked to that. They are as good as burned because they cannot be utilized ever. So it may not impact the total supply which is actually in the market. Some of the use cases for burning is one, we want to have a deflationary trend. So there are quite a few blockchain protocols. What they do is they are minting new tokens, but at the same time, they are collecting gas fee in the form of their native tokens, and part of that gas fee or the full of that gas fee is burned. So that way they reduce the supply in the market and create a deflationary token economics. So for deflationary purposes, burning of token is done. Sometimes it may be disincentive for a bad behavior. So there are a lot of disincentives that we see in blockchains, whether, let's say, when you stake on any proof of stake blockchains, there's always a disincentive where whatever your stake has been, a part of that stake will be slashed if, let's say, the desired behavior is not met on the blockchain. And similar use cases for various other use cases where we see there's a disincentive. Now, that slash tokens again can be put into treasury and can be burned depending on how the token economics have been designed for a specific system. And then, redemption is another use case. Like, if you go to Aave or Uniswap and you are a liquidity provider, you are providing liquidity. So when you provide liquidity, you get a LP token in return. So those LP, in that process, you can appreciate both minting and burning. So when you provide the liquidity at that point of time, you will get LP tokens, which basically is a receipt that prove that you have provided certain liquidity to a pool. And so these tokens are freshly minted, and you can hold these LP tokens. And whenever you want to, let's say, redeem your initial tokens, you can give this LP tokens back to the contract, and then you will get your original liquidity back. And at that point of time, these LP tokens will be burned. So and that's a continuous process that we see, whether you see Aave or Uniswap or any of these platforms. The next topic we are covering is incentives. We have briefly covered in various other topics. So, incentives and disincentives, I think, is one of the core uh, concept in the blockchain space. The whole idea of creating incentive is important when we talk about a decentralized system, because otherwise it is not possible to have different actors coming together, unknown actors coming together, working for a common system. So as we see, the miners and stakers who are managing the blockchain, they have an incentive to do it, and they don't do any bad behavior. It may be downtime, it may be writing wrong blocks, etc. So there's a disincentive. So that's why incentive and disincentives are very important. Incentives are two types. One is a staked incentive, and that's very straightforward, as we talked about when you are staking on a blockchain like a proof of stake blockchain, or let's say you're staking in any pool on Pancake Swap or Sushi Swap. So you get rewards based on that. So because you're staking, you're reducing the supply in the market, and it gives more stability and less volatility to the token. So you are rewarded based on that. And then there is a disincentive also. A slashing happens if there's an undesirable behavior for a specific application. There are direct incentives. Direct incentives, as I mentioned, like early users of a platform. We took an example of NFT marketplace, where early users, early adopters of a platform are incentivized in the form of tokens. Uh, Second, we classically we see in the case of liquidation. So in a Aave lending protocol, what happens is you have taken up a collateralized loan from the Aave protocol, and the value of the asset that you provided as collateral has dropped significantly. So your loan has become under collateralized. Now, in that case, there is one option that you can, deposit additional native tokens, that your additional collateral, to match the under collateralization, and make it at par with the conditions. Or second, else if you don't do that, then there are third party liquidators who can liquidate your position, and these liquidators will be then, once they liquidate the position, they will be rewarded. So these are direct rewards. They may get 5% of um, um, the amount that they liquidated, or whatever, depending on the protocol or depending on the contract. um, then we have swapping. So the classic swapping that we see is the decentralized exchange. So decentralized exchange, as we see, there's a history. So there's an order book matching. That's how decentralized exchanges initially started, very similar to centralized exchanges, but here there's a on-chain or off-chain decentralized order book. So there are primarily two mechanisms today. One is the order book matching based mechanisms. Second is the automated market makers. So we'll just briefly touch upon these two. But yeah, in the subsequent webinars, we are going to get deeper into these topics like decentralized exchange. So in the order book matching, what happens is the order, there are buy orders and sell orders, and they are matched with each other. The challenge with order book matching is that it's not a 24/7, because it may be possible that you want to buy something but there's no seller at that point of time, or there is a seller but the you're not able to achieve a certain price point where you are both agree to buy and sell, or execute the transaction. So, but order book matching, there are few platforms like Gridex is a platform which is running an order book based decentralized exchange entirely on chain, and then DYDX is an example of off chain order book DEX. Um, but then, when Uniswap came up with this concept of liquidity pools, that there's a liquidity pool where there is a pair of token liquidities provided by liquidity providers, and then anyone you can go, and you don't need to wait for buy and sell, because both the buy and sell price is quoted by the automated market maker within the smart contract, and you can simply go on Uniswap or Sushi Swap or Pancake Swap and schedule a transaction, and execute the transaction. So that is what how automated market makers based swapping happens. So the essential primitive DeFi primitive that is being used in DEX is the swapping. And again, if you remember atomicity that we talked about, that becomes very important. So you're not, when you are doing a transaction on Uniswap, So you say that, okay, I have one ether, I want to convert that ether into USDT, and there's a code for ETH slash USDT. There's a code of, let's say, $1,600. And if you execute the transaction, one ether will be deducted from your wallet, and you will get 1,600 USDT in return. But if there is any challenge, price change or any challenge, you're always in control of your funds. Either you will have one ether in your wallet, uh, if the transaction doesn't happen, and as the transaction happen, you will have 1,600 USDT and no ether in your wallet. So that way, uh, you are in complete control of your funds at all point of time. Then we talk about loans, one of the most exciting use case in the financial services space. And we know that lending, borrowing, is one of the most common financial services that we use today. Um, in DeFi, what we see are collateralized loans. And what we mean by collateralized loans is that you can go on protocol like Aave, you can put in a collateral. So let's say you have Ether and you want to, you have some need for funds right now, but you don't want to sell your Ether because you're holding those Ether for a long term. So you can go on Aave protocol, you can deposit your Ether, and whatever, there's a collateralization ratio depending on the asset liquidity. So if you talk about Ether, which has got a huge liquidity, lot many users who are transacting it on a daily basis, so there's a lesser collateralization ratio. But if there's a more risky, largely illiquid asset, the collateralization ratio will be a bit higher. So by collateralization ratio, I means that, if let's say you deposit one ether, which is hypothetically, let's say, equal to $1,000 today, so you will get only 60% or 70% of the loan against that. Very similar to what we see in the traditional finance. Normally, you don't get loan which is equal to the value of collateral. It is somewhat lesser than the value of the collateral. And again, the idea is that the value of the underlying collateral may change over a period of time. So to mitigate that risk, there's some difference between the value of the collateral at the time of providing the collateral and the loan that you get. So that is how collateralized loans work. The example of Aave, etc., is crypto collateralization, where you are providing one crypto and you are taking loan against that in the form of another crypto, another token. So Aave, Compound, MakerDAO, there are some of the protocols where you can take crypto collateralized loans. And then, one small concept within lending is the flash loans. And this is something unique for DeFi. That's why I've specifically mentioned it here. So flash loans are uncollateralized loans. Let's say you want to take a loan, you have to provide a collateral because otherwise there would be an inherent risk of not paying back, right? But as we know that DeFi is composable, and at the same time there's a property called atomicity. So out of that property, you can actually design a set of transactions whereby you can take a loan, and by end of the transaction you pay back the loan. So if let's say you are able to take a loan, hold it for some time, and then do something with that loan, do some set of transactions with that loan, and then repay the loan in the same set of transaction, in one single transaction from the smart contract perspective, then you can actually take a loan. So that is what a flash loan is. And today we see Aave, DYDX, and quite a few other platforms, they support flash loans. There have been a lot of challenges also in the flash loans. A lot of flash loan attacks have happened in the last few years. But understanding a simple flash loan, why somebody would take a flash loan. So the one of the commonest use cases, arbitrage opportunity. So let's say there are two dexes. On one dex, you are getting a certain token in $10. A token is being traded at $10, and there's another dex where the same token is trading at $11. So there's an opportunity of $1. You can actually buy from this dex A at $10, and you can sell it on dex B, and you can earn that 10% arbitrage opportunity or 5%. Sometimes the arbitrage opportunity may be small, just 1%, 2%. But if you talk about a larger loan, let's say if you can deploy $1 million, then even 1% or 0.5% will become a significant profit opportunity. So that's where flash loans happen. Taking a simple flash loan example, let's say you take a $5,000 flash loan on Aave. You use that flash loan of $5,000 to buy Link on Uniswap, and then you sell that Link at a higher price on FTX, and then once you have sold it, you've got the your money back. You can repay the loan on Aave, and including the interest, and still make a small profit out of it. So that is how a typical flash loan works, and it is again based on the property of atomicity, and so that because you are doing, if you see in this example, you are actually doing a transaction on three different platforms: Aave, Uniswap, and FTX, right? So similarly, there are flash loans where you can have set different number of transactions. There are various platforms which help you design these set of transactions, like InstaDApp, where you can design or code these set of transactions in one single shot. But the primary condition is that the loan has to be repaid in the same transaction. So that is how flash loans work. So this is, I think, we covered different primitives today. I hope you've got the brief. These are just the summary, or you can say a small description of each of the different primitives. And in the next two webinars, we'll basically dig deeper into some of the important topics, like whether we talk about tokenization of assets, or lending, which is itself a big topic, then decentralized exchange, how that work, and we'll do some, we'll see how dexes work. If you are new to DeFi, you would be able to see how these platforms work, how easy it is to connect your wallet and do the transactions, and so on and so forth. So just in the end, before we take up the questions, where Zeeve, I'm the co-founder of Zeeve. Zeeve is one of the leading blockchain infrastructure as a service platform in the world. We have 27,000 plus developers, Web3 startups who are using the platform. Zeeve supports 40 plus blockchain protocols today, providing full node, archive node, elastic APIs. So anybody who is building on DeFi can use our platform to connect with different blockchains, build your dApp, and get to the market sooner. Thank you.
So I hope, yeah, now everyone can see the QR code. Thank you, Dr. Chamria, for such a great continuation of the first topic. Now we can proceed to the Q&A session. And let me check the live chats. I see a question on our YouTube channel, but just a second, let me check another source and we can start. In the meantime, please scan the QR code of Zeeve to proceed to registration. Let me bring it this way. Uh-huh. So the first question comes from Malik. He says, "What are some of the most promising DeFi projects you have come across aside Zeeve?"
So okay, so when you say most, see some of the there are very large DeFi platforms today. So some of the examples which I gave, like Aave, Compound, MakerDAO, Uniswap, SushiSwap. So across and InstaDApp, and then there are Nexus Mutual. There are various like in the case of insurance. So across all different financial services, as we see in the traditional finance, we have now products across all different financial areas. In the case of DeFi, also there are a lot many promising projects. You can check websites like DeFi Prime, which basically list all the projects based on different categories. So you'll get to see all different kind of projects which are there.
Okay. So please feel free to leave your questions in the live chat. And since there are no questions, Ravi, could you please make a small spoiler maybe about the next session? What will be the topic of the next one?
Yeah, so in the next session, as I mentioned, we'll dig deeper into decentralized exchange lending. So we'll take 2 3 use cases, and we'll see how that works. How to set up a MetaMask wallet, connect with different DeFi applications, how to use the wallets. So today we talked about the primitives. Now we'll jump onto the use cases, and the subsequent webinar is basically knowing more about these use cases.
Okay, so I think that's very good approach to show about the advantages of DeFi. How is it useful for a regular person? And maybe in the next session we will make have some hands-on experience about the wallets. And another question comes from Chris. He says, "Can a LP token be an NFT?"
So see, LP token by default, it can be, but yeah, if you talk about, let's say, we talk about lending protocols, where the whole idea is that the LP tokens is now, being used for yield farming, and I'll touch upon yield farming in the next series. So if you're using that LP token in the yield farming, or let's say you want to trade this, use this LP token, you want to farm it, or you want to sell it on a trading marketplace, then ideally it should be a fungible token. So that's why the LP tokens that we see today, mostly in all the liquidity pools, is the fungible token. But yeah, these are ultimately, being a fungible token or non-fungible token is the standard. If your use case ask it to be a non-fungible token, you can design that. You can have a serialized ID to each LP token. It can be, designed like an NFT. But most of the LP tokens that we see today are fungible tokens.
Okay, let's wait for some other questions if there will be some new questions. And at this moment, I'd like to show another QR code that at Blockchain Professionals, we also have a community. That's not a channel, that's a chat where we can discuss different topics in different languages. And if you'd like to set up a new language, just let us know and we will create the chat. And now it's available in English, Russian, Spanish, and Chinese. Please scan the QR code and join our chat. And our next session will be on October 10th. That's in 3 weeks at the same time, also on Tuesday. And I see a message from Chris. He's the author of the previous question. He says, "Thank you. As a validator, we are looking at ways to incentives our delegators."
So frankly, I don't see a question there. Uh,
Yeah, that's a comment from the previous question.
Got it.
Yeah,
Thank
after
you.
your answer.
Okay.
So, yeah, I think then that's it for our today's session. Now we will conclude our today's webinar. Thanks everyone for coming. Thanks Dr. Chamria for delivering such a great presentation. Very eager to see what will be the next session, and wish you good luck. And this recording will be published on our YouTube channel. And if you have some questions, just leave them in the comments, and we will address them directly to Ravi. This concludes our today's webinar. Thank you so much. Stay tuned.
Thank you.
Bye bye.
Thanks. Bye.